Hello and welcome. It's time once again to try to fix something, and today on the workbench we have a PS4 Pro. I'm not sure the exact model. It's one of the earlier Pros. It's got the large full-size power connector, standard IEC plug. So let's show what this one is doing here. If we could eject, we do beep, power, we get a blue light, and we cut off. And we don't make any other noises. No other beeps, no other lights. Unless you cycle the power on it. Unplug it, plug it back in, and then you get another shot at it, I believe. Now, as soon as it gets booted up inside. Eject. And that's it. So that to me looks like a power supply issue. That looks like the supply is not coming up, but in this case it's actually, when it shuts down the standby 5 volts also. So not only is the 12 volts not coming up, it's shutting down the 5 volt standby part of it also, which is a little different. But anyway, let's confirm that's what it is. I'll get it open here, and we'll hopefully, I've got a supply I can swap in there. I think I do, and we'll confirm that's it. One thing to note, screws are missing on the back. And so somebody's been into this thing already. They may have already tried the supply. Let's find out. Alright, so I found a supply in my pile of parts over here. Not really sure if it's good or not, because it looks like it worked one time, maybe it didn't work the next. I'm not sure if it's any good or not. Let's just see what happens. My monitor's going to sleep. Wake up, we may need you. So, no power? Nothing. Alright, so my spare supply is not so good. If I can show you, I've got it hooked up here. It's not plugged in. It's plugged in back here. The power is connected, but I don't have it set in the chassis. I'll show you right down here, like on this first pin on the upper right. We've got 4.81. That's good. But on this, the next pin would be ground. The next pin over here would be the enable for the 12 volts, and this one over here should be the power good signal, which is low. That should be 4.8 volts as well, to let the console know that it's safe to power up, which is why right now, even though it has 4.81, it's not going to try to turn on because the power good signal is not high. But never fear, I dug through my parts and found another one. Let's see if it does any better. Okay, I want to see if this plus 12 is coming up. And I've got my probe on it here. I'm grounded over here. And I have unplugged the supply and plugged it back in, so we've got another shot at this. I want to see if that 12 volts is coming up for a moment. And I don't have enough hands to do this. Let's see how this works out. I can press this. We did come up momentarily. It was quick though, and right back down. Not good. Alright, I'm in resistance mode. I want to show you if I get right across the terminals for this plus 12 volts. If I can do this. Alright, let's just stick our ground probe back here. I don't have enough fingers for this. Okay. 1.6 ohms. And how much is the resistance of the leads? 1.1 ohms. So if we have a less than 1 ohm short. So, yeah. There's our issue. We got a dead short somewhere on the 12 volt line. Hold up. Did I just screw up? Look at those terminals. They had to have pushed together again. So before I go any further, although I've got it all the way out of the case, before I go any further, we're going to put this thing back in here. Well, for that, let's just check right now, if we can. Do we have our short across the 12 volts? I bet we don't. I bet we don't. Just some stupidity on my part. Just a little. Nope, still 1.6 ohms. So that wasn't the issue, but those leads sure are bending. But yeah, that still looks wrong. Well, maybe I'm not that crazy. Let's get it inside of the workbench. All right, we are in at the workbench. I want to try to get an accurate measurement of this short. So I've got some short leads here on my meter. I got it nulled out to eliminate the resistance of even these short leads. Now, can I do this with one hand? This should be ground side. And there's the positive side. What do we get? 0.27 ohms. That's a pretty dead short. Sure would be nice and convenient if it was just one of these little bypass caps or something somewhere on the board. But I think it's time. I've taken a glance around the board. I don't see anything obvious. But I think it's time to get the thermal camera out and maybe inject some voltage. All right, well, I've got my supply set for 5 volts, 1 amp. Let's see what's going to happen here. There are some reflective spots. Don't let those fool you. But at 1 amp, it may not be enough current to find anything, but we'll start there. We are drawing 1 amp, 0.67 volts to get that 1 amp of current. So is anything getting hot? That's because this is 0.673 watts of heat going somewhere. Somewhere. So far I just see some shiny spots. That's some of the shiny polished chrome on the board. Let's flip the board over, look at the other side. Oh. Only thing I look like the processor is getting warm. That looks like the only thing getting warm. See a slight heat spot there in the middle. It's slight though, right where the processor is. That's just a shiny part there. Yeah, there's nothing going on here. Not quite sure why the processor would have power on it with just applying 12 volts. Seems like the 5 volts and 3.3 and all that stuff would have to be up before we would try to send power to the processor. Okay, I'm still trying to find this short, and it's so low, it's really hard to narrow down with a meter, and it was hard to narrow down with the thermal camera, but I may have to just increase my current. But what I'd like to do is 12 volts enters this part of the circuit that generates the supply for the processor over here. It all enters through this coil right here, it looks like. There's no convenient fuse for me to lift or anything just to confirm it, but this coil, this side is tied hard to 12 volts. So if I lift this, that should pretty well narrow it down if our short is on this side of something else on the 12 volt rail, or on this side going to the APU processor power supply. So I think that's my next move is just to lift this and see what happens. Alright, so our coil has been lifted, and on the input side, back toward the 12 volts line, there is 1.76 k ohms. So yeah, and on the side going toward the APU, 0.23 ohms. So we definitely have a problem on the CPU side. Now, is it the CPU or is it one of these switching devices? I don't know, because 5 of these are paralleled. It looks like 1, 2, 3, 4, 5. This one is actually isolated. It must be a different input to the processor, but these 5, the inputs and the outputs are all paralleled. So really any of them could give you a short. So the next step I may have to do is remove each one of these coils, try to isolate it down to see if it's, here or on this side. That's all I know to do at this point. Alright, so I've been removing these inductors one at a time. Started with the one closest to me, and after each one, I was removing with low melt solder, by the way, because I was trying not to heat up any of these capacitors around here, and because some of these will explode if you get them too hot. But with low melt, it's easy to replace them and easy to remove them. So I removed this one, measured my resistance, no change. And this one, no change. Then I got to this third one, and now, we're 900 k ohms right there now. So I believe what that means, because these things are all parallel. That's how I'm isolating. I'm isolating this stage from this one, and I didn't make it to those, but by lifting that inductor, I'm isolating their outputs, because these things should not be shorted through. They just shouldn't be. That they're supposed to be switching devices. You should not have a short. Now, even though this is low impedance going into this processor, you should be able to see it from out here, not without the power on, not without everything running. You just shouldn't see a low impedance. So anyway, I think our problem is going to be this chip right here, because when I removed this coil, which connects this IC on to the rest of the bus going to the processor, when I lifted that one, now my resistance reading is running around in the hundreds of k ohms though. So now I've got to see if I've got one of these. I think I have a board out there in the garage that has a dead CPU, and be a prime candidate to donate a chip for this board. Before I go out and get this other board to pull the chip off of, I need to check something. I'm zeroing out my meter. That's pretty darn close. What is the resistance going into our processor? .22. Not sure, that may be a little low. Because my concern is, of course, if one of these chips here shorts, you have the possibility of getting 12 volts straight into your processor, which it cannot stand. So I'm going to try this. I'm going to try swapping out this IC. But I'm thinking this resistance right now should be something closer to 0.5 ohm. So, yeah. Well, we have replaced that one IC that was shorted. I've reinstalled the coils that I removed to troubleshoot these right here, as well as this bigger one, inputting in all of the voltage there. And I can tell you, if we measure right here to ground, we are in the, well, it varies around k ohms. I've seen it say hundreds of k ohms. I think we're biasing some stuff on, see 1 mega ohm. So we are high impedance at this point. We're no longer shorted, and we should no longer be shorted here, right? 1.5 k ohms. So that's good. Let's take it back out in the garage and see what happens. It may all blow up, but that's part of it. All right, we are back out in the garage, and we have got it assembled, I think, to the point of testing. Does have a hard drive in it. I didn't forget to clamp the CPU this time. I think my button and light ribbon cables are connected. Are we feeling lucky? And I've still got my test supply in there. Eject. We have standby power. Well, we should. We knew we would have that. Let's see. I don't believe it. She didn't die right away. Fan is spinning. Blue light's flashing. And I thought I saw the monitor. We're going to safe mode. All right. So the processor is not dead. I am amazed, because that was a low resistance reading, which apparently is completely normal. How little did I know. So what? Oh, 5.05 or later. This has got some old software in it. Okay, well, I think I've got a copy of that around, or I may just take it. Probably just go ahead and take it to 9. I know I've got that right here. Go ahead and start that process. And okay. And I'm going to bet the power supply that came out is perfectly fine. Well, that's exciting to see. It's actually going to work, I think. Okay. Well, it was fun while it lasted there, but our console that worked for about 10 seconds has now turned into a blue light of death. And my fear is that the APU has finally died, but I'm just kind of surprised it wasn't dead already. It actually came up and worked for a little while. So just to explore every last possibility, I'm going to pull the flash, the NAND, off of this board, and we're going to check it for corruption, because that can cause a blue light of death. Now, how it got corrupted, I don't know, but I'm going to check it, and while I'm in there, I will enable the serial UART output, so we can serially we can monitor the status of the system as it tries to boot up, and maybe we can get some clues as to why it's not starting up now. So I went about removing the flash memory IC so that I could read its contents and check it with the Better Way Electronics NOR validator. And it read fine, read contents out just fine, and when I did a check, it was perfectly healthy. So corruption is not going to be the issue. I did enable serial output while I was in there though, so at least I was able to do that. Alright, our NAND has been flashed to enable the UART output. I've got a serial cable connected to be able to read it on my computer here. Let's see, let me get some power. And let's see what happens. And that's it. That's all she does. And there's no more. I think our processor is dead. I'm afraid that's going to be about the end of the line for this one. We've done about all we could. Well, I think our processor just got 12 volts at some point and was overstressed. But I hope that was somewhat educational and entertaining. We can't win them all. If you liked it, please give me a thumbs up, and I will see you in the next repair. So long for now.